So we'll title this the ambiguous case. First of all, we recognize that we can use the sine law because we have an angle and its opposite side and one other piece of information. So here, angle, its opposite side, one other piece of information, that tells us we can use the sine law. Now, when figuring out what's the first thing you're going to be able to find, you always look at the extra piece of information and you can find out whatever is opposite of that. So at this point, we can find out angle P, but we won't be able to find out angle Q or side Q yet. Yes?
I thought the ambiguous case doesn't work because 7 could be like quadrants.
Well, the ambiguous case, the reason it's called ambiguous is there could be two triangles, but we also saw if the side was way too short, there could be no triangles. Well, it could be a hypotenuse, but we don't know that this is 90-degree angle triangle or not. There's nothing that indicates, other than the 50 degrees, what kind of triangle this is. So what I like to do whenever I have an ambiguous case is the first thing I like to do is draw my two triangles. Okay? And I personally always like to put the angle in the bottom left-hand corner. For me, that helps because that's sort of like the activity I showed you at the beginning. The adjacent side that we know is 7. I like to always put that up there. Because then I can imagine sort of this line here could go there, or I could swing it around and it could go there. Can you imagine that same length of 6 could go in either of those two places? So what I do is I draw 1 out here and label it with 6, and then I draw exactly the same and have 1 come back. Well, here, I'll draw that better. So I got my 50-degree angle here. So in one angle, this side here will be an acute angle. In the other triangle, this side will be an obtuse angle. Now, as far as doing the math, if you follow the math, you will always solve this first triangle first. So when I do the math here, I'd multiply both sides by 7. Sine P equals 7 sine 50 over 6. And I'm just going to type that in so we can see what that decimal would be. 0.8937. Now, the reason two triangles appear at this point goes back to what we were learning about the cast rule and about sine. Notice that when I typed 7 sine 50 over 6, I got 0.8937. Can you see that this is positive? That's a positive number. It's not negative 0.89, it's positive 0.89. When is sine positive? According to the cast rule? In which quadrants? That one and this one. Quadrants 1 and quadrants 2. So when we solve this with our calculator by going sine inverse, like P is going to be sine inverse of 0.8937 dot dot dot. When we type that into our calculator, which quadrant does it give us? It gives us the answer in quadrant 1, 63.3 degrees. Which of those two triangles did I figure out? I figured out this one, 63.3 degrees. If I found the one in quadrant 2, again, you imagine an angle in quadrant 2 is 63.3 degrees as its reference angle. What is this angle that's going to be left? 116.7? So that's going to be this one, 116.7 degrees. Okay? There's two ways that people make sense that it has to be 116.7. The way that we just did was using the cast rule and saying we've learned that sine is positive in quadrant 1 and quadrant 2. So that's why we get one answer that is the 63.3 and one answer that's 116.7. The other way that some people like to see this is if I drew both of these triangles simultaneously on the same one. This is my 7, here's 6, or here's 6. Can you see that the big triangle is this one, and the small obtuse triangle is this one? So another way that people like to see why is that other angle 116.7? When you figure out this one is 63.3, what kind of triangle is this one right here that it's not part of either of those two triangles, but do you see we have an isosceles triangle here? So if this is 63.3, this is 63.3. Because the two sides are the same, so the two angles have to be the same. Yeah, they don't look the same. That's yeah, I've been gone, so my triangle drawing skills have. Yeah. And then these two have to add up to 180. So that's another reason that it would have to be 116.7. Okay? So to recap, we noticed that we can use the sine law. Okay. We notice we can use the sine law because we have an angle and an opposite side. We can first find the thing opposite of the side that extra piece of information. Here we realize there could be two possible triangles because the side opposite the angle is less than the adjacent side. So I drew both triangles out. This is a very important strategy because if you just I find if you try to do them all together in one, you get confused with what angles you have. So drawing them separately is really helpful. Some questions will ask you to solve the entire triangle. So you still have to find those other two sides. But now that you've got these two angles, can you see you can find the third angle? And then once you've got that third angle, to find the side opposite it, you could use the sine law again. And then you would find everything on the triangle.
How do you know the right triangle is 7?
So this, on the right triangle, this part here stayed the same. That's part of what was given originally. I just took this triangle, my original blue one here. Can you see that I rotated it so that my 50 would be in the bottom? I find it's easier to draw that way. And this side here would be 6. So that 6 side could either go this way or that way, and everything else would stay true. And then you could find the other side. So this is an example of the ambiguous case. You recognize you can use the sine law, but that opposite side is smaller than the adjacent side. I'll make up another example here to show you what happens in the ambiguous case. Let's say you're given this information. There's 30 degrees. This side is 8. This side is 2. Can you see that you can use the sine law? Because you have an angle and an opposite side and another piece of information. Can you see that this is the ambiguous case? Because the side opposite is smaller than the adjacent side. So there could be a possibility of two triangles. This example, when we do the math, we're going to find out that there's no triangles. What does it look like when there's no triangles? Because on the last quiz in inequalities, when I had a question with no solution, you guys all are like, my calculator is giving me errors, I don't know what's wrong. something weird is happening. So it's nice to see what does it look like when something weird is supposed to be happening, when there are no solutions. So we set this up. The first thing we're going to be able to solve for is this angle right here. I'm going to put theta there. I've got this on the same video, so if you want to watch it later, you can look at it. So here, we want to find sine theta. Opposite it is the 8. On the other side, we'll have sine of 30 over 2. Notice that when I'm solving for angles, I put that on top. When I'm solving for sides, I put those letters on top. So sine of theta equals 8 sine 30 over 2. And now this would be a non-calculator question. Mental math. What is 8 sine 30 divided by 2? Mental math. That's right. Good. It's 2. How did you do that? Because you know what sine 30 is. Sine 30 is a half. What's 8 times a half? Divided by 2. 2. And you say, well, Mr. JR, if I have sine theta, I need to do sine inverse. How could this be non-calculator? You should know when you look at this immediate that there's no solution. How do you know that? Okay. Maybe it helps if I write 2 over 1. What is the definition of sine? Sine is what over what? Opposite over hypotenuse. Draw me a triangle where the opposite side is 2 and the hypotenuse is 1. You can't do that. So when you have this number and it's bigger than 1, you won't be able to draw that triangle. That's why there's no solution. If you go to your calculator and you try to type in sine inverse of 2, it will give you an error. So this question could be on a non-calculator part of a test. And you'd feel like, I should know, I don't know if I can do that without a calculator. Well, all the values are there that you know. You get something that there's no solution, so you wouldn't need your calculator for that as well. Although if I put this on the non-calculator, then you would also know right away that there's probably no solution. So I'll put it on the calculator section anyways.